then we start with a little trip back to algebra where we discuss transformations. Okay, I hear a phone crying. I hear it. I need like a little sound effect. Okay, phone needs a nap. And we had these 4 different transformations. We did vertical stretch and shrink. That's this guy. That's probably what you called it in your youth. Okay, officially you can say the graph with y values scaled by a factor of a. Oh, does it shrink or shrink? Dr. Shrinker. There used to be a cartoon when I was a kid and it had Dr. Shrinker. I should look that up. Well, we also did Shrinky Dinks. Yes, back before video game, back before electronics. We did Shrinky Dinks. Okay, you also move stuff to the right and to the left. Okay, that was a horizontal shift, which is actually what we're going to cover today. You also did a horizontal stretch or shrink. And we did that yesterday when we putzed around with the period. And finally, you move vertically. We're going to do that next week. That's a vertical shift. Okay, I kind of wanted to save the easiest one for last because it's better than sort of ramping up all the time and like saving the hardest thing for last. So, they actually did the hardest thing yesterday. All right, so what does this look like in terms of trig? Well, your trig function looks like this. You've got some number a multiplying either a sine or a cosine. I'm just going to write sine for now because the rules are the same. Whether it's sine or cosine doesn't matter. So I'm just going to write sine down. We had this transformation b, which affected our period, and plus or minus c. So these are the ones we're doing so far. Again, as a review, a affected the amplitude, which was the height from the midline to a peak. And if you want a little picture of that, I can throw that in there. Yeah. This is an amplitude right there, that little height. So we did that yesterday. We also talked about B yesterday, which was a horizontal stretch or shrink because it either lengthened or shortened your period. But
that's horizontal.
Yes, B is not the actual period. It just changes it. B is not the actual period. B is the number of cycles, and by cycle we mean the shape, between 0 and 2 pi. B is the number of times the graph oscillates between 0 and 2 pi. How are we doing? Okay, all right, next, phase shift. This is the horizontal shift. We're moving to the right or moving to the left. Okay? Move right or left. And this is going to change your starting point.
That's the vertex.
Well, it used to change the vertex, yeah, when we were talking about parabolas, and that was your starting point. Trig graphs don't really have a vertex because they kind of go up and down and up and down and up and down. But you do have a particular point that from which you are going to launch your wave. Okay? So just to be clear, though, it does not mean that your wave is moving right or moving left. It's the starting point that you choose to sketch is moving to the right or to the left. Okay? Where was our starting point yesterday, like every single time? At x equals 0, right? You started 0, and you went up, down, up, down, up, down. Okay? We are not going to start at 0 and go to the left right now. We're going to take that starting point and we're going to adjust it. We're either going to start to the right of where we're used to, or we're going to start to the left of where we're used to, but that graph is still going up and down to your right. Okay, it's just where you choose to start it is going to change. All right? If your graph says, or your equation rather, says x minus c, are you going to go to the right or to the left?
To the left.
I wish we were going to the left. You know why I wish we were going to the left? Because everybody looks at that and thinks left.
So it's like
Unfortunately, we are going to the right. Okay, move your starting point right, C units. If your equation says x plus c, you are going to move your starting point
To the left.
to the left C units. To the left, to the left. And basically, if you've got x minus your x plus c, c is going to be your starting point. I'm torn about this. I've gone over this midpoint thing twice, and it doesn't seem to have helped anything. So maybe we'll come back to this. But just in general, midpoint is the average of 2 points. Okay? Let's just maybe leave it at that. Okay, and midpoint is going to be the average of 2 other points, and this will come up later. By the way, if you'd like to take a baby calc at this time because you've got like fraction phobia or post-traumatic fraction syndrome, get it out, because we got a lot of like a little, it's not like horrible fractions. I'm not going to have you do like 117, 130ths or anything, but we got to be comfortable adding stuff like fourths and halves and things like that. Okay? The reason I'm saying get out a baby calc if you have one is because when we go to graph these things, like actually in a test, you are not going to be allowed to use your graphing calculator. All right? So maybe starting tomorrow, I do have some baby calcs in storage. I can kind of pull those out. Okay? Only if you need fraction support. If you don't need fraction support, dude, you're going to be so glad. You're going to be so glad you don't need the fraction support. But if you need it, it's okay. All right, let's find this page. And I'm going to zoom in on number, I'll go number 1. Why not? Okay, are you ready? Number 1. Well, it's pretty similar to what we've been doing with one exception. What's the exception? Look at the equation. What's different?
It's
minus 5.
Yeah, you got an x minus pi in there.
oh, that's right.
Okay? Yeah, so something's moving to the right, right? So the whole thing's getting shifted to the right. So this means that sine x is shifted right pi units. You should write this down because this is notes. This whole page is notes. I don't know how many of these examples we're going to do, but we're going to do some of them, and then the rest of them I'm going to post so that you have a nice healthy assortment of examples to refer to. Okay, so this sucker all got shifted to the right pi units. What are your key points for sine? What's your pattern? Mimmel or Himmel? We start in the middle or a high or a low or what? What do we start on for sine? Sine swoosh. Uh-oh. Middle. We start middle, high. Did I not do this in this class? Yeah, we did? Oh, okay. Well, that's when you made me key points. So we go middle to the high to the middle to the low to the middle.
What does that mean?
That's the pattern of the cycle that we're going to draw. Yeah, I think you had to leave before we did this.
Goes high, low.
Yeah, so it's going to look like this, Bruce. It's going to be one cycle of sine looks like a weird S. Yeah, so this is the middle. This is the high. It's a sine wave. Thank you. Middle.
Oh,
I'm just going to quit and let, you
you
know.
always stop
Deanna
right there,
teach a class.
like at that line.
Well, one cycle does. Okay? A true sine curve is a series of these cycles over and over and over again. It's a bunch of these little snake things like attached. Okay?
Yeah.
But when we graph, we need to be able to know that what one cycle is. And that's this. So when it says key points, it's middle, high, middle, low, middle. Cosine is going to be a little different. All right? 2 pi over b. Why are we doing 2 pi over b? Because we want to know what the period of the graph is. We want to know how long the cycle is. What's b in this one? Where's your b at? Where's your b? B, where's that money? What's b?
Yeah, what be
Well,
So when we go forward, the would be 1.
here's the template. Forgive me for use of the word template. Yeah, it's 1. We got an A, a B, and a C. A is to the left of the sign. B is between the sign and the X. C is to the right. So B in this case is 1.
What if the age is that like the vertical stretch?
Yes. Yes. So really we're not stretching anything. The only thing we're changing is we're shifting. The period is still 2 pi. The period hasn't changed at all, right? Because B is still 1. Lauren?
How'd you get, why is B 1?
Because You see this x over here? What's the coefficient of this x?
Oh.
1. It's the coefficient of x. B is the coefficient of x, pretty much. Okay? Your left endpoint is this new piece that we're talking about now. Where's my other favorite pen? No, my favorite pen is not red, but I suppose given the circumstances, we could leave it like that. All right, so your left endpoint is going to be pi. Nobody see what I did there? Nobody?
No.
Never mind.
What?
It's okay.
Wait again.
It's gonna be pi, so what is it?
That means instead of starting at 0, we're going to start at pi. Okay, so your left endpoint of the cycle, this is your left endpoint right here.
That's gonna start at pi.
Okay, that's going to start at pi. So put yourself a nice red dot right there.
So you're always gonna
So,
start.
If it's in this form, yes, absolutely. Okay, if you've got an x minus or an x plus something, that thing that's getting added or subtracted off the x is where you're going to start. Deanna?
Will we be able to fit a whole like swoop test within 2 pi?
Well, we got to go, now we're going to, basically what we're going to do is we're going to add a period onto the endpoint. Yeah. Okay, so your right endpoint is going to equal the left endpoint, and I'm writing this for note's sake, plus period. Okay? Your right
so that would
endpoint,
be 3 pi.
it is 3 pi, you guys are fast. So you're going to go pi plus the period, which in this case is 2 pi. And that means your right endpoint is at 3 pi. So go ahead and draw your right endpoint of the cycle.
Is the period always gonna be 2 pi?
It is not. Yeah.
So
If the number next to the x is,
no-
well, we'll get there. We did that a little bit yesterday, but we're gonna throw that in today too. Okay? Today, right now for this problem, Bruce, we're just focusing on just phase shift. That's it.
Can we do cosine one after?
Absolutely, we're gonna do cosine. You're reading my mind. All right, we got to get 3 more points in here. So the sine pattern has another point
Oh,
dead in the middle there.
It'd be, so between pi and 2 pi, it'd be high, and then you go low.
Yes, between pi and 2 pi you have a high. Between 2 and 3 you have a low. But what are those numbers?
1 and
1/2 pi, or
1 and -1.
1 and 1/2.
Well, the y's are 1 and -1. What are the x's? So let me clarify the question. What is this? What the heck? What are those x's right there? What's the x between pi and 2 pi? Should be 3 pi over 2. This is where the average of the 2 points comes in. You're doing the average of 1 and 2, which is 1.5. What's the average of 2 and 3? What is the number on the number line that is halfway between 2 and 3? 2, 3. 2.5. Okay, how do you turn 2 point?
5 pi over 2.
Thank you, Bruce. Bucce for the win. Okay? This is where the calculators might come in handy. If you can't, if you kind of struggle with that. Okay, you're finding the average of 2 and 3. The average of 2 and 3 is 5 halves.
First one, 3 pi.
Because that is the number between 1 and 2. What number is between 1 and 2? Exactly. 1 and a half.
It's a fraction of 1/2.
It's the fraction version of 1.5.
Oh, okay.
Yes. Yes. Sydney.
Do you even need to write that though?
Yes. Yes, you do. The 5, no, I'm glad you asked that question. The 5 key points are the kernel to this whole thing. Okay? They're what generate the curve.
So even if it doesn't touch it on the actual line?
Correct, because guess what, Sydney? That is the ordered pair. I'm only doing it this way so you don't have to write the whole ordered pair thing. We could just write 5 ordered pairs too, but that's a lot more work. Okay, so it does matter, right? It's just instead of writing it as ordered pairs, like this ordered pair here would be 5 pi over 2, comma -1. Guess what, Sydney? Nobody wants to do that. So I'm trying to at least keep the important information without forcing ordered pairs. All right, so the request has been made. Let's head on over here to number 2. What's the only difference between 2 and 1? It's cosine. That's the only difference, right?
It's complementary.
It's a it's a co-function. That's true. It's complement. Yeah, standard complementary. Good, Bruce. I like he's got some recall. Otherwise, everything else is the same, right? So this is cosine moved to the right pi units. The pattern is a little different. You remember what the pattern is for cosine?
Is that the only difference? It's like the Himmel one.
Himmel!
Yeah.
Cosine cup. high, middle, low, middle, high. Okay, Mimmel and Himmel. It forms a cup. It's gonna look like this, Bruce. High, middle, low, middle, high. High, middle, low, middle, high. Okay, unless it's flipped over, but this one's not flipped over. Has the period changed from our original, from the parent graph? No, B is still 1. So your period is still 2 pi. Your left endpoint is pi. Right? That's this guy.
Yeah, that's
Okay, x minus means moves to the right. Means you're starting at pi, right there. Okay?
So is that the high?
That was the left side. That's this guy right here, left endpoint.
Yes, that'd be the high.
Yeah. The right endpoint equals pi plus 2 pi. I feel a strange sense of deja vu. So your endpoint is 3 pi, just like we did before. Which means you're going to have a high over here at pi 1 and a high over here at 3 pi 1.
Wait, how did you know to add pi plus 2
Wait, why do you?
Because your right and left endpoints are 1 period apart. Okay? Here's your left endpoint. Here's your right endpoint. The gap between them is a period. Okay, so you start with the left, add a period, bam, you got your right. Let's find where the low goes. Where's the low going to go?
Wait, where is this? Why did you start at the 1?
Why did I start at 1 pi? Or the 1?
No, like pi
Mhm.
comma 1.
Because your amplitude is 1 here, which means all your highs are hitting at 1 and all your lows are hitting at -1.
Oh, so for sine, is that you don't do that?
No, because sine starts at a middle. Goes middle, high to 1, back to the middle, low to -1, back to middle. You know what? Hand for Bruce. He's doing 2 days in 1 here, because this guy wasn't here for this yesterday, so he's doing awesome.
So for 1, the high would be 1. Right?
Yes. For problem number 1, which we graphed a sine? Yes. Okay. Come on, pen. All right, so then the last thing we got to do is throw the middles in here, which we already figured out from problem number 1, that's 3 halves and 5 halves. There we go. So 1 and 2 look a lot alike, right? It's just that one of them is,
And then they're different shapes.
they are different shapes. Their starting and ending points are the same, right? The cutoffs in between are the same. The only difference is the shapes, the pattern that you follow. Okay, so does that answer your cosine question, Deanna, pretty much? Okay,
Are we
good.
gonna do one for tangent or no?
You know, I wasn't planning on it, but if you want, you know, today for sure, no, not today.
No.
Are we
Well, no, I don't want to make you, but I'm thinking for extra credit, somebody might want to learn some tangents. Maybe. Let's see how it goes, Brooch. Let's see how it goes, okay? I love that you're excited about it, though. I love that.
Can you show us what the difference is when it's a plus pi?
Wow, absolutely, because guess what's next? 3 and 4. Do you love how I'm reading your mind like that? Is that amazing?
Be on the left side.
Yeah, pretty much. Abigail.
I have a question.
Yeah.
This is really on top, but for the cosine,
Yeah.
if it's negative, do you start at like say it's like -1 cosine?
Yeah.
Do you start at -1 or do you start at -1, right?
You start at a low point. You're looking at like, oh, I don't know, number 10, right? Where there's a negative out in front. It means your highs become lows and your lows become highs, basically.
Okay, so it doesn't. So it's like. Okay, never mind.
It's not affected by any horizontal changes.
Negative for sine and you go down, but then so it's the opposite.
Yeah, in both cases, the highs and lows switch locations. So Anna, what do you want? 3 or 4?
Let's do
3? Okay, 3. All right, so our left endpoint, our key points are still going to be middle, high, middle, low, middle, right? We're good with that. Okay, if you're tired of writing that, that's fine. You don't have to, but it's kind of a nice reminder. What's the period of this function? It is still 2 pi. No changes have been made there yet. Okay, we might want to do that next. Okay, period is still 2 pi. What's your starting or your left endpoint?
Pi.
Close. It says plus, which means you're moving to the
Yeah, so
left. So you're actually starting at
negative.
-pi. Okay, we move to the left. When it says plus, you move to the left that many units. So we're starting at negative pi. And how do we get the right endpoint?
You add 2 pi, or negative.
You add a positive 2 pi. You add a period to that. So negative pi plus the period, which is 2 pi.
3 pi.
This time it equals pi. So this time your cycle is going to end at positive pi. Deanna?
Okay, so when it's going left, it's not like flipping around.
Right.
It's still.
Exactly. It's the
I think
starting point that
I
moves
think
left.
The A is negative.
No, she's meaning like if I'm going to start here and just start my swooshing to the left. No, we don't do that. We always swoosh to the right. Okay? So now we start at negative pi. This is your starting point. This is your ending point, right or left and right. I hope that was helpful. Okay, the middle. Can you see the middles here at 0? That was easy, right? That's the halfway mark between negative pi and pi. Nice. And we shouldn't need calculators for this one. How about this second point here? How much is that?
Which one?
This one right here. What's that?
Negative 1 half pi.
Negative half pi. Negative pi over 2. And what's this guy here on the right? Positive pi over 2. And we throw a high over there and a low over there, and we're good. Okay? That's a scary red, isn't it, on the screen? It's kind of scary looking. That's right. Meanwhile, in my uterus, just kidding.
Wait, I got a question. So what is the
Just kidding.
what?
Question, Bruce.
So what's the B mean?
Let's do some B. Let's get after some B. Ready? Here we go.
That was great, Jay.
Dudes, you are ready for number 11. Let's do 11. Here we go. Oh, yeah. We're going 11.
Oh my god, that's awesome.
I love that Bruce is like, yeah, I have no idea what you're talking about.
Yeah,
It's okay. It's okay. What
Wait,
the-
you're going to Princess Anne.
Is that wrong? Does that mean I got to edit that out? Yes.
Wait, are we not doing?
You always got to throw a little something in there so people are like enticed to watch it. I should do like a subliminal flashing of the meme in there. Have you seen that meme? Oh, it's a good meme.
Have you seen the Vanderlei?
Yes. Oh my gosh. Okay, pause. No. All right, so we're going to do problem 11, and then period 4 is going to take a little trip to the Rainbow Sponge Lady. All right. Key points. What are they?
How did he get here so
negative 3 pi over 2.
I love you, Bruce. No.
Alright,
You're so
3 pi
fearless.
over 2.
You know what? Key points is the pattern. So it's the middle, high, middle, low, middle.
Oh,
Should we appease Abigail and throw a little reflection in there? Or?
Hold on, where? What are
No? Okay, I sent somebody to. We're on number 11.
Okay. Okay.
Middle, high, middle, low, middle. Okay, so there's that shape again. It's going to get kind of boring after a while, but it's okay. Oh my goodness, we have a period change. Okay, what's B? What's B?
B is 1.
Where is the B located?
In front of
After
you,
sign.
it's two,
After
it's two
sign.
in front of X.
After sign.
Yeah, this is B right here. Yeah, B, B. B, where my money? Okay, that's B.
Yeah, no, we went to 11.
Yeah, we went to 11. We're ready.
I thought the
We're
B was
good.
outside.
Okay? So guess what? Your period's shorter now. Okay? The cycle's moving twice as fast, which shortens the period. Period's only pi now. Here's a question. What the heck is your left endpoint? We have two candidates for left endpoint. Do you see what I'm talking about? Is it this one or is it this one? Answer. Do you see those two equations there?
Uh-huh.
Yeah.
Is it the
It's this guy right there. Okay?
Can you explain why?
Yeah, because in order to fit the pattern, which says x plus c, x minus c, you have to have it where the x is alone. So you got to factor the two out, which I did for you already, and I will probably continue to do that just for now. So your left endpoint is 3 pi over 4. I don't want to confuse you. This is another reason I'm making the...
It's always what's gonna be like.
If your x minus is alone, and it's cozy little parentheses, right? It's going to be that number that's in there with the x. Okay?
We're going to be expected to do that.
No, I think I'm going to do it for you.
Thank you so
Okay?
much.
But I wanted to show you where it came from.
So for the right EP,
Oh, he's guessing. He's going for the right EP.
2 pi, right?
Hold on a second. Right EP equals, what do you start with? 3 pi over 4
Plus pi.
plus pi. Very good. Okay, and if you get a baby calc out right now, I will not judge you.
Oh, yeah.
Pi. 'Cause you
Oh, I
do 4 pi
love
over
you so
4.
much. What is 3/4 plus 1? If you have 3/4 of a pizza plus another whole pizza, which we did, had Lou Malnati's last night, despite the Cubs' loss. It's 1 3/4, which is 7/4. Boom. Okay? 3/4 plus 1. Right endpoint. Right endpoint. What is where the cycle ends, Asia? Okay, it starts here. This is where your cycle starts. This is where your cycle ends. Uh-oh, we lost Asia. What can I do for you? You sure? Okay. All right, so now I got to go find 3/4 on the number line. Can you go find 3/4 on the number line? There you go. Go on a little search right there.
The,
There it is, right there. Is that where you said it was? 3/4.
oh, I'm at the wrong one.
How did I get 7? Well, it was 3/4 plus 1. You got 3/4 plus $1. What is that?
Oh, okay. 175.
175. How do you turn 1.75 into a fraction? 7/4.
Or could you just like throw a 1 under the pi and then the 1 under that has to be equal to 4, and so then you add the 4 onto the pi and
4 pi over 4. Yeah, absolutely.
yeah, that's what I did. in my head.
That would be awesome. If I could get everybody to do that.
I just understand.
Okay, where's 7/4 on the number line? Oh, there it is. Oh my goodness, 4th periods, adding fractions with unlike denominators, y'all. It's a beautiful thing. Love it.
Now it's 4 pi over 4, so you just add 3 pi plus 4 pi.
Are we good? We got our starting, we got our ending. Sydney,
Okay, they're a little bit confused. I feel bad. 'Cause
That's
I'm
okay.
not doing this right.
That's okay.
Sydney's just
4
mommed
over,
up.
why is it 4 pi over 4?
Oh, okay. Can I take a little detour to the right here? Watch this, over here.
First time I thought it was that.
3/4 plus 1 is what's really going on here, right?
Yeah.
You have to change the 1 so that it has the same denominator as the 3/4.
Yeah.
Which means you change the 1 into a 4 over 4.
And then you add that.
Then you add the numerators, and bam! There you go.
Okay, now it's
Does that make
easy.
sense?
Yeah.
I don't know what I'm trying to explain.
That's awesome. Okay, so now we're back over here. We got our starting end, we got the left end point, we got the right end point. What's going to be halfway between 3 and 7? Dang it, Tetris. Well, we got 3/4, 4/4, 5/4. Right?
Sorry for my math.
My life
All right, 2 more. I'm almost done. I got the left is 3, the right is 7, the dead middle is 5. This guy here, oh, remember that? It's 4 pi over 4. It's halfway between 3 and 5, isn't it? What's halfway between 5 and 7? 6. So that's 6 pi over 4.
Oh, we gotta write all these down.
Yes.
Oh.
6 over 4, which is 3/2. Nope, we got to get to this first. Okay? So now we got to figure out where does the high go and where does the low go.
The high goes on the 1 between pi.
Well, it would go on the 1 except that there's a 2 in front, so. No, it's okay. This is as hard as it gets. This is it. So that means your high goes to the 2 and your low goes to the -2. And there it is. Woohoo! Okay? That's it. That's as challenging as we're going to get at this point. Okay, again, I will post all the answers to all this sheet. All this sheet. Okay. What is she ready for? The sponge lady?
I'm ready for
Okay, can I just tell you what your homework is, though? It's well, it's only 8 problems. There's only 2 graphs on a page.
Problem.
Okay, there's only 2 graphs on a page. It's just really spread out. Okay. Should we put sponge lady in the video?
Sponge lady
Yes.
in the video right now.
Okay, here we go. And then we'll do classroom IQ.
I'm really excited. Like, I'm
It's like an Easter egg.
ready to go.
Oh my gosh, I can't wait to tell Fiona Watkins that she needs to watch this video. I
Yeah,
Oh
another.
my
wait, we need speaker. Speaker. Is this like, does it matter which one or is this a good enough one?
They're all the same.
That's like a highlight. So. You wanna pause the views?
Well, do I or do we want it on there?
You need a recording.
No, you want this.
Come on in.
You asked for it. A whole video devoted to the rainbow sponge. The Army Arts and Crafts Department sent me to Korea. Now, not a normal sponge. This is so dense. 3 sizes because
I feel like this is me
can't
talking about
use
Trig.
one size. Another thing that I want to talk about is the hygiene of the sponge. I squeeze and squeeze and squeeze and squeeze.
No
Look
flab
on
on
this
this
side.
side.
Clean. Flab
Flab on this side.
Now, if you do get it on your hands, gloves are incredible. I have a pure glove sponge that is absolutely pure. Virgin edge. Oh my gosh. I'm sorry. Oh, I want you to look at all of those wiggles. Oh my gosh, wiggles. Oh my gosh. I love to wiggle the whole thing. There are many other surfaces that you can sponge on. I'm sure you would. Of course you can go straight.
I'm crying.
Look at this, cool.
That's a fake.
Okay. Calm down, dear.
Well, it is kind of like edited, you know.
Yes. You see that?
Earth tone.
Is this fun? What?
Aiden, I know what to get you for Christmas.
Moving heavy.
This is how I feel when I'm doing the keys for your homework. You don't understand.
Oh my gosh. Now, think, go this way, and now we zigzag. Oh my gosh. Oh my gosh.
That's cool. Come on.
And then,
Come on.
oh, this is one I feel like it's so hard to stop.
That was awesome. I will be forever grateful to Jana.